Hello viewers, in today's session we are going to discuss another important problem from derivatives in which we are going to find out the derivative of this function f of x is equal to sine of sine x using first principle, right? So let us start. Now see, we have already discussed a lot of problems related to finding out the derivatives of functions from first principle. So to use this first principle, we start with the definition of derivative of a function. Now see, if we have a function, say y is equal to f of x, then the derivative of y with respect to x, which is f prime of x, is given by this limit, that is limit h tends to 0, f of x plus h minus f of x divided by h, right? And here h is a very small quantity, which is infinitesimally very small, right? So we'll start with this limit to get the derivative of sine of sine x. So now we have a limit h tends to 0, f of x plus h can be obtained by replacing this x by x plus h. So we have sine of x plus h, and then we have f of x, which is sine of sine x, and here we have h. Now to simplify the numerator, we can make use of an important identity from trigonometry, right? So if we take a is equal to sine of x plus h and b as sine of x. So let us take this sine x as b and sine x plus h as a. So now we have this identity, that is sine A minus sine B is equal to 2 times cos A plus B over 2 and sine A minus B over 2. So we'll apply this identity to simplify the numerator. So we have limit h tends to 0, and here a sine of sine x plus h. Sine x plus h is a, so we have sine a minus sine b because sine x is b, and here we have h. So now we can write limit h tends to 0, and we have 2 times cos a plus b over 2 and sine a minus b over 2 divided by h. So here we can write h. So now we have limit h tends to 0, 2 by h, and we have cos, and for a we can write sine x plus h plus b is sine x and divided by 2, and then we have sine, and a is the sine x plus h minus sine of x, b is sine of x divided by 2, right? So now we have to evaluate this limit. Now to evaluate this limit, what we will do, we can write a limit h tends to 0, and we'll first write this expression. So we have cos of sine x plus h plus sine x divided by 2, and then we can take this expression, that is 2 over h over here. So we can now write limit h tends to 0, and we have 2 over h and sine, and here we have sine x plus h minus sine x over 2, right? So now we have the product of two limits. So let us call this limit as L1 and this limit as L2. So now let us separately find out L1 and L2. So L1 is given by this limit. Now here we have limit h tends to 0. So let us take h is equal to 0 over here. So we have cos and then we have sine x plus 0. Then we have here sine x divided by 2. So we can now simplify it. Cos, we have sine x plus 0 is sine x. So we have sine x plus sine x, that is 2 sine x divided by 2. So now we can cancel 2 and 2. So we are left with the cos of sine x. So the value of the limit L1 is given by cosine sine x. So now let us find out the value of the limit L2. So we have limit h tends to 0, 2 over h sine x plus h minus sine x over 2. Now to simplify this term, we'll again make use of this identity, taking a as x plus h and b as x. So we have limit h tends to 0, we have 2 over h sine, and we can now write 2 times cos uh, a plus b over 2. So we have x plus h plus x over 2, and then we have sine x plus h minus x over 2, and this 2 is given by here, right? So now this 2 and this 2 get cancelled. We have limit h tends to 0, 2 over h sine, and here we have x plus x 2x. So we have 2x plus h over 2, which can be written as x plus h over 2. So here we have cos x plus h over 2, and then we have sine x and x get cancelled, so we have sine h over 2, right? So now to simplify this limit, what we will do, we'll write limit h tends to 0, 2 over h. Then we have sine of uh, cos x plus h over 2 and sine h over 2. So we'll multiply the numerator and denominator by this term, right? So we can now write here cos x plus h over 2 sine h over 2, and to cancel out this term we'll multiply here by cos x plus h over 2 and sine h over 2. So in the next step, what we will do, we'll take this term, that is 2 over h over this term, that is here we can write h over 2. So now this limit L2 can be written as the limit h tends to 0. We have sine, then we have cos x plus h over 2 sine h over 2 divided by cos x plus h over 2 and sine h over 2 multiplied with the limit h tends to 0. We have this term, that is cos x plus h over 2 multiplied with the limit h tends to 0, and we have this term, that is sine h over 2 divided by h over 2. So now we have the product of three limits. So now let us evaluate these three limits one by one. Now see, here we have sine of this term over this term, right? That is cos x plus h over 2 sine h over 2. Now see, when h tends to 0, then we have this term also tending to 0, that is cos x plus h over 2 sine h over 2 also tends to 0. So if we take this term as say theta, then when h tends to 0, then theta tends to 0. So this limit is now equal to limit theta tends to 0 sine of theta over theta, where theta is cos x plus h over 2 sine h over 2. So when h tends to 0, then this term, that is sine h over 2, it tends to 0. So this entire term tends to 0. So it implies theta tends to 0. Then we have limit h tends to 0 cos x plus h over 2. So when h tends to 0, we have simply cos x plus 0, right? And then we have limit h tends to 0 sine h over 2 divided by h over 2. So when h tends to 0, then h over 2 also tends to 0. So again we have this form, that is limit theta tends to 0 sine theta over theta, where theta is equal to h over 2. So here the value of this limit is equal to 1, because limit theta tends to 0 sine theta over theta is equal to 1. So now this limit is equal to 1. So we have L2 is equal to 1 times cosine of x times 1. So this is equal to cosine x. So the value of the limit L1 is equal to cos of sine x, and we have just seen that the value of the limit L2 is cos x, right? And now the value of the derivative, that is dy over dx, is equal to the product of these two limits. So L1 is cos of sine x, and L2 is cosine x. So the derivative of this function, that is sine of sine x, is given by the expression, that is cos x times cos of sine x. So this is how by making use of the concept of first principle, we can easily find out the derivatives of functions.